Okay, so we start. Am I audible? Hello?
Yes, sir, you're audible.
Yeah,
Yes, sir. You are audible.
yeah. So what we are going to study in this class today is the Wagner Whitin model.
Sir,
Yeah,
sir, I have a request to made.
yeah.
Please, can you use whiteboard for the class?
That's what I am doing.
Like write with pen, sir.
That's what I am
Instead of
doing.
instead of typing, if we can do with the pen and write with the hand, that would be easy.
Okay, but okay. I don't have the related equipment. I will get it. This is also good enough. Let me see. Okay,
Yes, sir. Sure.
I will do it from the next time. So today we are going to. Is it visible to you?
Yes, sir.
Yes, sir.
Is visible. Okay, yeah. So what I'm saying is today we are going to study the Wagner Whitin model. See, as I told you in the first class, now we are going to relax the simplifying assumptions one by one and move towards a model which is as general as possible, you know, which can be applied to a many a situation. So that's our objective. So in Wagner Whitin model, what we assume is the demand is dynamic. So let me clarify between the dynamic and probabilistic. Dynamic means that the demand is deterministic, but is different in different months. Okay. So demand means it is lumpy. Okay. The first month, the demand could be 10, second month, it could be 100, and in the third month, it could be 50, and so on and so forth. So what would happen is in this scenario, you will not be able to apply the EOQ model so easily. Okay. But still, many practitioners may take the average demand and apply the EOQ formula, but that will not give you the optimal solution. So then Wagner Whitin developed this model. Okay. So what I am going to do is I am going to send you the original paper by Wagner Whitin, and I will send what are all my notes that also I'm going to send you. The paper is based on a few theorems and results. Okay. And as I told you in the first class, this class is not about theorem proving. Okay. But given the results of a theorem, we can draw certain inferences and develop an algorithm, and that we can apply to solve problems. Okay. So theorem proving is beyond the scope of this course. So let us consider a small problem. We have a time here, which is the first month, second month, and we have the third month. Okay. And we have demand as 10, 100, and 50. We can have the concept of setup cost. And I have to shift these things on the right hand side. Let the setup cost be 50, 60, and 40. Then we have inventory carrying cost. We say it is 1 unit, rupees 1 per unit transferred to the next period. Let me write down what I'm saying here. So inventory carrying cost, I will call it a ICC, equal to so we say that ICC is 1, or I could make it 2 also here. That is to make it as general as possible. And I could make it 3 here. But all that is required is it has to be positive. Now, what would happen is in the first period, I might produce 100, so I transfer 90 units of inventory to the next period. Okay. And if I do that, then I will incur a shortage of 10 units in the second period if I don't produce. Okay. So what we assume here is that shortages are not allowed. Shortages are not allowed. And there is one more assumption which will be clear as we go along. So let me come to this place, and suppose we have following the production schedule. I will call it a production schedule. I'll call it production schedule. Okay. And this I have here, I produce 20 here. Okay. Then I produce 140 here. And then I produce 20 here. So what would happen is, so then what will be my cost? How much will be my cost? So I will just calculate how much inventory is carried forward. Inventory carried forward is, inventory carrying forward is, 10 is carried to the next period. And how much inventory is carried to the third period?
So 50.
Yeah?
Here 150. Entire 50 will be carried forward. 140 plus 10 minus 100.
It will be 160 minus 110, so it will be 50. Isn't there something wrong?
So for the period 2, 140 plus 10 will be produced. Production is 140 and 10 is being carried forward. So total we have 150 units, out of which 100 will be consumed in time 2, and we are
Here
left with.
Here that quantity transferred will be 30.
Oh. So,
See, what is happening is we are producing at the end of the 2 periods is 160. And
Hmm.
just make a small change here. Here production is 0. Okay. Then it will be clear. So now here the quantity transferred is 50. Okay, that's fine. Is it all right now?
Yes, sir.
Because total quantity produced will be 10 plus 100 plus 50. So that will make it 160. So that's what we have produced.
Yes, sir.
Now what has happened is you can note an important thing here, that in period number 2, this following thing has happened. In period number 2, following thing has happened, which means that inventory T star XT, XP, or rather I will call it PT, is greater than 0 for period for T equal to 2. Right? In period number 2, I'm producing 140, and at the same time I'm carrying 10 units of inventory. Right? So can I reduce the cost? Professors Wagner and Whitin argued that such a schedule can never be optimal. What can be done? Why do you think it is so? See, what can be done is I could produce, whatever is this 10 units, these can be produced in period number 2 itself. Okay. If I have the schedule like this, I produce 10 here, and I produce 150 here, and I produce 50, and I produce 0 here. So what I have done, what is the reduction in cost? Can somebody tell me what is the reduction in cost? Reduction in cost is how much? You see, what I have done is I have transferred these 10 units, okay, to be produced in period number 2 itself. Okay. So the total quantity produced is 150, and I have reduced the production in previous period. Okay. And what has happened is I have saved 10 units of inventory carriage. Okay. Reduction cost is 10 units of inventory carriage. Ten units of inventory carriage to period 2 is saved. Saved, and production is transferred to period 2. Now, Professor Wagner argued that this will reduce the cost. Can somebody tell me what is the assumption here?
So no shortages are allowed. That means the production has to be.
Shortages are not allowed. Shortages are not allowed.
So immediately the production has to be supplied. Like I need 150 units, so 150 units has to be supplied to me. Immediate replenishment.
See, what has been done is I have saved 10 units of inventory. Okay. And what I have done is production from period 1 is transferred to production in period 2. That's what I have done. Okay. And now it is argued by Professor Wagner and Whitin that the cost will be less. So what is the implicit assumption that is being made? That's the question.
So the assumption would be that our
Yes, can
production
somebody
schedule
tell?
Sir, the production schedule is always meeting the demand. That's the assumption.
Yeah, production schedule is meeting the demand. It is obviously the shortages are not allowed.
But sir, How can we know beforehand what are the demands?
Which one?
So how can we know the demands beforehand? While production scheduling, we don't know the demands, exact demands. We need to predict.
Dynamic demand is dynamic, so this is the inherent assumption which we made. Like it is deterministic.
Yeah.
Okay.
See, there's a difference is demand is dynamic. Dynamic demand means it is deterministic. It is with a probability 1. But demand is lumpy as it is, 10, 150. It is not uniform as was assumed in EOQ model. And as we said in the first class, we said that we are going to relax assumptions one by one. So this is the relaxation in assumptions that we are making. Now I bring you back to this production schedule. It is 20140. Now the production schedule is 10150. So what has been done is I have saved on the 10 units of inventory which were transferred from period 1 to period 2. Okay. And if the production cost of this revised schedule 10150 is to be less, what one more assumption is required? That's the question. Can somebody? It's very simple. Let me put down.
Sir, production cost should be
Production
uniform.
cost is same. Production
Same.
cost in period 1 is same as production cost in period 2 is
Then it works.
in period. Okay. So I have explained to you the theorem in a simple manner. One more assumption that is being made here, I will write down here itself, or I will write down here that production per unit production cost per unit production cost is same in all the periods. So with this assumption, okay, Professor Wagner Whitin argued that such a schedule I'll just write down here, such a schedule will never be optimal. So this is the fundamental result. You can very easily see that it will not be optimal. Suppose you have a schedule for which IT times PT is greater than 0, E equal to 2, and we have the assumption that a per unit production cost is same for all the periods, then such a schedule IT star PT greater than 0 will never be optimal. So that is the fundamental result of Wagner and Whitin. So now having done that, let me, so shall I erase this portion? It is clear now?
Yes.
Hello?
Yes.
I clear this.
Hello, sir.
Yeah.
Sir, will you be uploading these videos as well?
Yes,
Like
yes,
this?
very much. I have uploaded previous videos.
Yes, sir, I saw. But
Yeah.
this also.
This also, all videos will be admitted.
Okay, sir. Thank you so
Videos
much.
will be uploaded. Okay. So this is the fundamental result of Wagner Whitin, and many more results will follow, which are highly intuitive, and I am not going to prove it. Okay. Those people who are mathematically inclined, they can refer to this paper and enjoy the theorem proving, but it is beyond the scope of this course. Okay. This course, we are not doing theorem provings. Okay. So with this and your permission, I will erase this board, And I have made very clear this particular fundamental result. Very simple. So now what I do is I take up a example, which is a 12 period example. And then we are going to solve it. I'm calling it as month. Okay. And then we have here S is the setup cost. And then I have all these periods here. So I call it 1, 2, 3, 4, 5. So we have a 12 period problem. And we have the setup cost as follows. I'll just write down. You can take down also so that it becomes the more practice you do, this concepts more sink into your mind. So from that point of view, you can take it down also. So I'm going it slowly. So these are my, some of the parameters of the problem. So let me write down here that it's a Wagner Whitin model. Now I have one more thing, which is the demand. Demand is as follows. 69, 29, 36, 61, 67, then it is 45, then it is 67, then it is 79, and then it is 56. Okay, this is my demand. And I'll put down the inventory carrying charge. Inventory carrying charge is Inventory carrying charges. P1. By one period, right? So these are my parameters of my problem. Okay. Now, as the result says, that IT star xt equal to 0, we had the schedule there. We had a schedule 10 and 150. So the first period we produced only for the first period. And in the second period, we produced for second period and the third period. Okay. So what you do is in a 12 period problem, in the first period, either you produce first period, second period, third period, fourth period in the first period itself. And then in the fifth period, you produce for fifth and sixth, and so on. Such a schedule can be optimal. So Wagner and Whitin, by this property, they have reduced your search space. Okay. By arguing that IT star PT production should be greater than, should be equal to 0, means inventory is positive, production has to be 0. Okay. So we'll take this example one by one. Suppose I produce in first period. Suppose I produce in first period, what will be my cost? Yes, please.
So the cost will be demand is 69 into the 85.
No, this is S is my setup cost. Let me give a this thing here. Okay, so what I mean is S is setup cost. And D is demand, right? So S is my setup cost and D is my demand. So how much, and I have assumed in the Wagner Whitin model, that per unit production cost is the same. So subject to this, whatever will be my production cost, 69, 29, 36, I will incur the total cost of total demand into production cost. That will be a fixed cost and that will not change. So let me exclude that from my calculations. Am I clear?
Yes, sir. That will be something which is
My
constant
cost of 69 plus 29 plus 36 plus 61 plus 61 up to 56.
into P. That is the production.
Whatever is my per unit cost will be the same for the entire 12 period problem. Okay. So that I did not calculate. And for the sake of, comparisons, I will say that I incur a cost of 85.
Okay, sir.
Now suppose so if it were just a one period problem, so what I want to tell you is, I will just write down here 1 and I will delete it because I have loss of space. Or what could be done is we could erase these 10, 12 periods so that it becomes easier because the board size is limited. So we are not considering a 12 period problem, but we are only considering a 9 period problem. So while I make this rearrangement, so just bear with me. Okay. And now I make this also aligned so that I have space for these quantities that periods, which I am going to, which are very important. Okay. So if I produce in the first period, it is optimal for the first period. Now I consider a 2-period problem. Okay. If I'm producing in period number 2, let's go one by one, Yeah, so Siddhant Modi, you would answer this question. Suppose I produce in so I said I will produce in period number 1, then my cost is 85. Can I produce in the first period? Now, if I produce in second period, how much is my cost? If I produce in second period, how much is my cost? Yeah, yes, please. If I produce in the first period, my total optimal cost is 85. And if I produce in period number 2, what is my total cost? Yes, please. 187. It will be 102 plus 85. Because the demand cost I am not going to consider. Okay. So the total cost now is 187. Okay. And I call it as producing in period number 2. I'm doing some rearrangements for the lack of space. Okay. Okay. Now suppose I am producing it in period number 1 itself. What is my total cost? Next person, somebody will like to say? Hello? If I produce in period number 1, what is my total cost?
Sorry, 85 plus 69 into production cost.
As we said that the production cost is same for all the periods. So in the first period, I am producing 69 plus 29. Okay. So that production cost is 69 plus 29 into production cost is ignored because anyway, I am going to produce for the entire 9 periods. Okay. Production cost is the same, so it is ignored.
Okay.
Okay, so what is the cost is I am incurring a cost of 85, which is the setup cost, and I'm transferring 29 units of inventory to the next period. So my total cost is 85 plus 29, right? So I
Yes.
write down here it is as 114. I see period number 1. Okay. So now which is the minimum here for if it were just a 2-period problem? If it were just a 2-period problem, then it would have happened that it is optimal to produce in period number 1 for period number 2 also. Okay, and not produce in period number 2 at all. Okay. So in your copies, you mark 114 by an underline. Okay. So, so now the next person, if I'm producing in the 3rd period.
Excuse me, sir.
Yeah.
So can you please repeat the last point? I mean, if we only produce in the first period, how is the cost 114? I mean,
114 is as
I'm
follows. I'm considering only a 2-period problem.
okay.
Right? Okay. And demand is 69.20. 29 production cost need not be there. So I'm producing how much in period number 1? 69 plus 29.
Okay.
Number 1, how much I'm producing? If I'm producing in period number 1 only for a 2-period problem, I'll be producing 69 plus 29, out of which 69 will be consumed in the first period itself, and 29 is the inventory carried to the next period.
Yes. So then, how it is 114?
It is 85 plus 29. 85 is my setup cost.
Okay. Sorry, I'm sorry. Yeah.
Yeah, 85 is my setup cost and 29 is the inventory transferred to the next period. So it will be 85 plus 29 is equal to 114.
Okay, so I get it.
So let us take turns and then answer this question. If I am going to produce in period number 3, what is my optimal cost?
223.
220?
3.
I'm going to produce in period number 3.
So 289.
Not 289. See, what I do is as follows. For a 2-period problem, I am going to produce in period number 2. So how much setup, and then what I will do is, for the first 2-period problem, I take the optimal cost. Optimal cost is 114.
Okay.
Okay. So for a 3-period problem, my total cost is 114 plus 102. Right? So it will make it 216.
216.
It will be for the third. Is that right?
Sir?
Yeah.
So from now on, like after we have got 114, now that becomes our optimal cost. So the third period will be calculated.
Optimal cost for the first 2 periods.
Yes, so for the first 2 periods, it has been calculated as 114. So now when we are moving into the third, and
Now I'm see what I'm doing is because of that IT into PT equal to 0 property, you know. So either in the first period I produce for all the see what we let it will be clear once I go to the period number 2 also. Okay. So suppose I'll answer that question in little bit more details as I go along. Okay. So just wait for a moment. I will stress this point again. Suppose I am going to produce in period number 2 and supply it to period number 3. What is my optimal cost?
114 plus 36.
No, I am going to produce in period number 2. So period number 2 is 187. 187 plus 36. It will be 223. And I produce in period number 2. Is that all right?
Okay, sir. And this is more than 216. So this is definitely not optimal.
Yeah, it is definitely not optimal. You are right. You are right.
Okay, so that is why we consider 114. We forget 187 because we have
Yeah,
obtained.
because because of this IT star PT is greater than, it should be equal to 0 for an optimal schedule. Okay. So I ensure that in a period, I don't produce as well as carry inventory, which means in the first period, I produce for first period, second period, third period. The second period, I produce for second period or third period, if it were just a 3-period problem. Or in third period, I produce for third period. Okay? No inventory is carried forward to a period where there is production. Okay. So now it will be more clear once I get down to the third one. Okay. Suppose I produce in first period. What is my total cost? I produce in first period. What is my total cost?
Sir, 85 plus 29 plus 36
Yeah, you are.
for the.
Please correct it again. 85 plus 29 plus 36.
Yeah. Plus 36 once more.
Plus 36 into 2.
Yes, sir.
85 plus 29 plus
Oh,
30.
yes, sir. Yes, sir. Yes, sir. Yes,
Because
sir.
आपने
36
यहाँ
into
पे
2.
पीरियड नंबर 1 में प्रोड्यूस किया है, 29 has been incurred for 1 period and 36 has been incurred for 2 periods, because 36 units of inventory is transferred from period 1 to period number 3, right? Okay. So my
Yes, sir.
cost is 85 plus 29 plus 36 into 2. Can somebody calculate and tell me how much it is?
180, 186.
186. 186.
186. Now we are here for a 3-period problem. Okay. If it were just a 3-period problem, I say that my optimal cost is 186. Okay. So are you convinced that all possible schedules have been considered before arriving at this optimal solution? Yes, because nowhere we have considered the case where production is also there and inventory is also transferred. Such cases have been excluded, and we have considered only those cases where IT star PT is equal to 0. Okay? And all such cases have been completely enumerated. Okay? So therefore, according to Wagner Whitin, the optimal solution for a 3-period problem is to produce in period number 1 for the entire periods 1, 2, and 3, and that is the optimal schedule. So now I get down to the next. So far, so clear. Any questions, please? You can ask me now. Yes, please. Hello. Any questions?
No, sir.
No. Okay. So now I produce in the 4th period. What is my optimal cost? So I produce in the 4th period. What is my optimal cost?
324.
See, what I do is as follows. I produce in the 4th period, so I incur 101. What is the optimal solution for period number 1 to 3? It is 186. Okay. So my total cost is 186 plus 101. which makes it 287. And I produce in period number 4. Is that right?
Yes, sir.
That's right. So now I produce in period number 3. So what is my cost? Can somebody tell? Can somebody who has not made attempt, because if I change over to that people this thing, then I lose this connection with the board. So can somebody else tell a figure? Doesn't matter even if you make some addition mistake. Doesn't make a big thing. I produce in period number 3. So what is my total cost? Yes, please.
Sir, 247. It should.
247. It won't be 247. See, if I produce in period number 3, my cost is 216.
Okay, okay, sure. Sorry. So 216 plus 61 for next carrying charge inventory.
So it will be how much? 277. Right? It will be 277, and I produce in the 3rd period. Right? Now, see, I have to consider all the periods. I'll explain to you that. So, is that all right? 277 is 216 plus 61 is 277. Okay. Now I take up the next one. I produce in period number 2. So what is my optimal cost? What is my cost? Not optimal cost. What is the cost?
284. So 260.
Now you tell me the
Oh, sorry,
components.
no, into two. Yes, sir. Sorry.
You
Sir,
tell me the
102.
components in detail. So don't tell me the correct figure. You tell me the components.
102 plus 36 plus 61 into 2.
See, the
Setup.
cost if I produce in period number 2 is 187. So it will be 187 plus 36 plus 61 into 2. Is it all right?
Okay. Yes, sir. Yes.
ये आपने second period में cost किया था आपका 187 आ गया.
Sir,
Plus
can you
36 plus 61 into 2. So how much is that?
Hmm.
187 plus 36 plus 61 into 2 is how much?
345.
Now I produce in period number 1. So what is my total cost?
$369, sir.
369. I believe your figures because I don't.
Yes, sir. 85 plus 29 into 1, 36 into 2, 61 into 3.
61 to 3. That's right. So I produce in period number. So what is my optimal cost?
277.
277. Right?
Third month. Yes.
So if it were a 4-period problem, my optimal cost is 277. So I produce in period number 3. And then for the I produce in period number 3. Okay. And then I come back to for the first 2-period problems. I produce in. Please complete the sentence. For the 4th period, I produce in period number 3. And for the 2nd period, I produce in
Period number 1.
period number 1. So I produce in period number 1 and I produce in period number 3. And the optimal cost is 277. And by the Wagner Whitin theorem, which says that IT star PT is equal to 0 for an optimal schedule, we are assured that 277 is the optimal solution for a 4-period problem. So now I get on to the 5th period. Suppose I produce in 5th period. How much is my total cost? Yes, please. Can somebody who has not attempted so far? Yes, please. I produce in period number 5. So what is my cost?
375.
370. You tell me the component. Yeah, 370.
Yes.
Tell me the
277 plus 98.
277 plus 98, right? So it is 375, and I produce in the 5th period. Okay. Now I come to the second one, in which I say that I want to produce in period number 2, period number 3. Oh, sorry, period number 4. I produce in period number 4. So what is my total cost? Can somebody else make an attempt?
Sir, 287 plus 61, 348.
348. That's right, 348. Okay. That means I have communicated correctly. Okay. Now I produce in period number 3. What is my total cost? Can somebody else make an attempt? Tell me the components. Total can be told later on.
277 plus 61 into 2. Total.
I produce in period number 3. So my
Yeah.
cost is
277 plus 61 into 2 for overall.
I produce in period number 3. So my cost is 216. Then I add to this 61 plus 61 into 2. So how much that becomes? Yeah, you are right in that way.
Yeah.
What is the cost? This cost is how much?
399. Oh.
Is it 409? Hello?
It's 399.
399. Okay, I accept that. Okay. Now comes an interesting result. So my result is I don't have to compute below that. That's what Wagner Whitin argued. So what he said is optimal solution for period 2 is period 4 is to produce in period number 3, which means it is not optimal to produce in period number 2 and transfer it to period number 4. So it is not optimal to produce in period number 2 and transfer it to period number 5. I will repeat. You look at a 4-period problem. It is not optimal to transfer from period number 2 and transfer to period number 4. Right? So it is not optimal to transfer production from period number 2 to period number 5. This is another result from Wagner Whitin. And it is very easy to see that if such a case is there from transferring from 2 to 5, okay, it follows from the simple result IT star PT is equal to 0 is there. And therefore, it easily follows that if it is not optimal to produce in period number 2 and transfer to period number 4, then it is not optimal to transfer from period number 2 to period number 5. Okay. So this has reduced my search space and my computations. Okay. So this result I am stating without proof. Okay. Then I again go ahead I come to this portion. Okay. So for a 6-period problem, I produce in period number 6. What is my cost? Can somebody tell?
$375 plus 114.
It will be 375 plus. I'm producing period number 6.
Sir, 348 plus 114.
114. 346 plus 348 plus 114.
114.
So that makes it how much?
460.
460.
462, no?
462. 462 I produce in period number 6. So then I come down to what I will. Okay, fine. So now I produce in period number 5.
The 375 plus 26401.
Yeah, I produce in period number 5. So 375 plus 26, that makes it 401. And this is the cost when I produce in period number. Period number 5. Okay. So now I come down to the next one. And what is my cost if I produce in period number 4?
348 plus 26 into 2, that is 400. No, 287 plus.
Is how much? It is how much?
So 400 means
400.
348 plus 52, 400.
Yeah, that's right. Or the other way of looking at it, my total cost in period number 4 is 287.
87.
Okay. 287 plus 61 plus 26 into 2, which is the same thing. It can be seen in many ways. So do I need to calculate for the third period also?
No, sir.
No, because it is not optimal to produce in period number 3 and transfer to period number 5, and therefore it is not optimal to produce in period number
3 and
number 3 and transfer it to period
transfer
number
to
6.
6, yeah.
So that's what I have gotten. So slightly this thing is displaced, so just bear with me. Now for the 7th period, I produce in 7th period. What is my total cost?
Sir, 400 plus 105.
505.
505.
505. 400 plus 105 is 505. I produce in period number 7. Then I come down. Then I produce in period number 6. How much is my cost?
462 plus 34.
34. So how much is that?
496.
496.
496.
496 if I produce in period number 6. Okay. Then I come down here. If I produce in period number 5, how much is my cost?
469. 401 plus 68. 34 into 2. 469.
469. I produce in period number 5. Now I produce in period number 4. So how much is my cost?
Sir, 400
400 plus
plus
34
102.
into 3.
400 plus 34 into 3. So how much is that?
502.
502. 502 into this is the fourth period. So again, the same question comes in. Do I need to produce? Do I need to produce in period number 3 to be transferred to period number 7? What is the answer to
sir.
this question?
No, sir.
No. Why?
Because it wasn't optimal to produce in period number 3 and transfer it to period number 6. So it won't be optimal for period number 7 also.
Yeah, that's right. Okay. So we have this this thing. So now comes a very important result. You know, now I'm considering the period number 8. So optimal is what now according to us?
469.
469 plus 86.
4 plus 86. Yeah.
469 is my optimal solution, right? I come to period number 8. So what is my total cost?
555.
555.
555. And this I am producing in period number 8. I come down here. So what is my total cost? I produce in period number 7. So what is my total cost?
Sir,
507. 505 plus 67. 572.
572 होगा. क्यों होगा 572?
505 plus 67 for inventory cost.
Yeah, that's right. So it will be 572. 572 and I'll be producing in period number 7. Okay. So again, I come down here. I produce in period number 6. How much is my cost?
Sir, 496 plus 2 into 67 equal to 630.
630. I produce in period number 6. Now I come down here. I produce in period number 5. Yes, please. Can somebody who has not attempted so far, can you take a call? The cost is how much?
670.
670.
Yeah. So how much? Tell me the components so that people can very easily make out.
69 plus thrice of
469 plus
thrice of
67 into
3.
67 into 3. So that makes it how much?
670.
670. And I'm producing it in period number 5. Okay. So now comes an very important result, okay, which says that for the 8th period, it is optimal to produce in period number 8. Okay. So now what are the implications for the 9th period? For the 9th period, what should be done? Can somebody tell what is in the 9th period? I produce it in the 9th period. So how much is my total cost?
Sir, 555 plus 119 equal to 674.
674. And I produce in period number
9.
9. Okay. And I come down here. If I were to produce in period number 8, what is my total cost?
555 plus 45. 600.
How much
600.
it is? 600. No, please don't be afraid. Please ask questions. कि कहाँ से कैसा आया बताइए. Any questions so far? So what is being said is, do I need to consider 7 for
No,
period
no,
number
sir.
9? No, because what
No.
happens is period number 1, see, it is not optimal to produce in period number 7 and transfer to period number 8.
8.
So it is not optimal to produce in period number 7 and transfer to period number
9.
Okay. So this is what it means. Okay. And this result is referred to as planning horizon problem. The period number 1 to 7 do not influence the future periods at all. Okay. And this is known as the planning horizon problem. And in similar way, you can complete the computations in the for the next period also, because of problems with the board. Probably I should choose a smaller font size. Okay. So this is what it is, right? So if I were to consider a 9-period problem, then my total cost is 600. And what are my production production schedules? I produce in home, where I do I produce? Okay.
8.
Period problem, I produce in period number
8 and 9.
I produce in period number 8 and transfer it to period number 9. What is the best schedule for period number 1 to 7?
Sir, for one it would be 69 because
469,
that
so I'm producing it in period number 5. Right?
yes, yes, sir.
I'm producing it in period number 5. And next, what happens? For period number 1 to 4, what is the optimal?
3 produce in 3 is the optimal.
Producing in 3 is optimal. For period number 1 and 2?
1.
This is what is our production schedule. The entire, and you can very easily calculate the production quantities given the assumptions that we made that IT star PT equal to 0 for the optimal schedule. So these are the places where I am doing the production. Okay. So we saw this. Yeah.
Sir, why don't we have any production schedule for the 4th period?
See, for the, I will go back from the 9th one. 9th one optimal is 600. Okay, and 600 says that produce in 8th period. So I'm producing in 8th period. So 8th period, I'll be producing for 8th period as well as 9th period. So now I will take up 1 and 7 separately. Now for a 7-period problem, my optimal is
5.
Optimal is 5. So I produce in period number 5. Now what is the best schedule for period optimal schedule for 1 to 4? It is 277. So I produce in period number 3. So I produce in period. And then I start worrying about period number 1 and 2, and it is optimal to produce in period number 1. That is 114. So this is what is my production schedule, which I can very easily calculate. Okay. And so if you go through the paper of Wagner Whitin, it is very complicated. In simple terms, what have we explained? We have explained dynamic programming forward recursion. Okay. So in very simple terms, we have explained this. Okay. But if you look at the original paper, which I'm going to send you, things are very complicated. And so this is what it is. Like we have done the forward recursion, Professors Wagner Whitin developed a backward recursion also. Okay. And that also is very easily possible. Intuitively, you can feel, you can find out that you can be very easily possible to develop a backward recursion. Also, the paper appeared sometime in 2004, but we are not going to consider. If a question comes on Wagner Whitin model, all you will be expected is calculate this table and prepare the production schedule 1358 and calculate this lower triangular matrix. Okay. Now, if I were a computer scientist or a OR specialist, I will like to find out what is the worst case computational complexity of this Wagner Whitin model. Given that number of periods are n, can somebody tell? What is the worst case complexity, worst case performance complexity of this algorithm? Yes, please. See, what would happen is in a worst case, I have a 9-period problem, and worst case, I need to calculate all the entries above the diagonal.
But it would be n square, no? For
It
the
will be
worst
O n
case.
square.
O n square. Yeah.
Yeah. So actually, it will be O n square by 2. So in terms of the
Computational, we just take
होता
O
है
n
उसमें
square.
ऐसा है कि divided by 2 को ignore कर दिया जाता है. Say that the computational complexity is of the order of O n square. I will write down here what does it mean. I'll write down here. This means it is written as like this: O bracket n. I'm not able to write n square, so I write it star star 2. Okay. The computational complexity of this algorithm is O n square. And typically in a Wagner Whitin problem, it's a dynamic programming problem. And if you don't consider this IT star PT equal to 0, complexity would have been enormous. Okay. And because of this simple equation, which reduces the third space, the computational complexity of this algorithm has come down. Okay. And OR specialists will be interested to find out what would have been the complexity of a Wagner Whitin algorithm. And typically what is being said is number of states are 1 to 9. And number of stages are 1 to 9. And number of states are whatever are the number of entries in the column, whatever are your production schedules. And in a dynamic programming scenario, the computational complexity increases polynomially with the number of stages and exponentially with the number of states. Since the number of states have been reduced drastically by the property that IT star PT equal to 0, we are able to get a O n square algorithm. But generally, for any kind of a OR problem, dynamic programming is the last technique of choice because of this property that the computational complexity increases exponentially with the number of states. Okay, so that part is ignored. So this is just for the sake of OR people. It doesn't make any difference to us. We have the result. All that is required is given an n-period problem, given this setup cost and given the demand cost, I can very easily calculate my optimal cost. Okay. So with this, I conclude. If there are any questions, I will take them. Otherwise, I will stop here. So those people who do not have questions, they can leave. And I'll be here present till the last person leaves to answer his doubts. Yes, please. Any doubts? Any doubts, please?
Sir,
हाँ बताइए.
sir, it is not from this class or the previous class, sir.
Yeah, what is the previous class?
So whatever we have done in the class, so that is not present entirely in the notes which you have provided us, the first, like chapter 2 which was mailed to us from the library.
Yeah, that's what I said. That chapter 2 is which I presented for a multi-item case is taken from Starr and Miller. Okay.
Yes, sir. So for
So
the
many
second,
books cannot be provided, and if you provide the photocopy of that book, then there'll be copyright problems. So I provided you my notes, and these are fairly self-explanatory.
so like I was requesting for the like previous class, the Lagrangian function which we have performed. So may you provide us with some more like Also, one of your copy of your notes handwritten PDF or any way where we can actually do the proper derivation like once more, because I might have missed out on a few derivation part, like a few statements in between. So, sir, if is it possible for you to, sir, please send us a note where you have written the entire derivation which we did in the class, so that we can tally it once and find out
See,
whether we have missed.
see, left hand side and right hand side, I leave it to you. It can be easily, very easily worked out. So you can just read yourself and convince yourself. Details are not with me. And this is a PG course. So, anyway, the result is there. You use it. I'm not asking you to derive anything. As I said, the theorem proving and derivation is not a part of this course. Only problem solving is important. Given the result, how do you solve the problem?
Oh, okay, sir.
And any kind of an
Okay.
exam will be an open note, open book exam. So I don't think that is going to matter.
Okay, sir. Okay. Thank you, sir.
Yeah, thank you. See, if you have doubts, then you wait. Otherwise, you please log out.
And so one more thing was there, the class was asking for a like digital pad where you can write or derive the formulas for that purpose
What is the
specifically.
problem with this portion? What is the problem with this portion?
So like this today, the portion was not at all difficult to understand from this part because it was clearly the tabulated form. It was good to understand from the written way. So last time, like for using sigma and summation, like we are used to a little bit of summation sign. That is where they faced the problem basically. So last time, that is exactly where everyone faced the problem, that they were not used to sum of I, the keyword. Rather, they were used to sigma I. So that is why.
Okay. So
So
just be, I mean, I have communicated my idea. I will try to get it, but you know,
you may use Jamboard also, because sir, once the class starts, then that iPad will be totally unnecessary. There's a Jamboard app with which you can use your mouse or touchpad to write. So only the formula part. Otherwise, this today, like the entire class for today, the tabulated form was very easy to understand.
okay, I will do that. I'll do that.
So I'll share something with you in the email, the Jamboard and all. So whichever is convenient for you. Otherwise, like for today's class, it was
But
very
sum
clearly
was just
understood.
very clear. What is the difference? Instead of sigma, it is sum over I. So instead of just sigma, that
Some
is
fine.
simple, I am just writing sum. So what is the big difference? Same thing will come in integral also. So what I am going to do is for integral, I am going to use the following term. You know, I am going to say integral int. I will say low limit and upper limit. That's all, and give the expression, and then write dx. That's what I'm going to do. Okay.
So then I'll share
Upper
this
limit,
with them. Like
comma,
I'll
upper limit and dx. Okay. So this is the way I have devised. So please bear with me.
yes, I'll inform them beforehand, sir,
Yeah,
about
and since it will be
the
available in notes, since the video is available, you can very easily watch.
go back and see it. Yes, sir.
Go
So
back.
this part I'll inform them beforehand.
Yeah.
The
By
integration
summation ki
side.
jagah sum, and see if you write it on a whiteboard on this thing, it becomes very neat, you know. Demand वगैरह अगर आप हाथ से लिखेंगे तो फिर मेरी हैंडराइटिंग समझ नहीं आएगी.
So mouse में नहीं होता, mouse और touchpad से नहीं होता. And once the class starts, then this entire concept of iPad and digital pad will be gone. So I'll inform them
Very
beforehand.
easy. See, I write these things in my research paper also, and they are accepted. You know.
Yes, so this I'll ask them to, like this. I'll share it in the group right now.
हाँ, देख share कर share कर.
Then it will be easy for us to like understand from beforehand
हाँ,
also.
सम की जगह सिग्मा है, इंटीग्रल की जगह ये है, मैं आपको बता देता हूँ. कोई बड़ी.
Yes.
Yeah.
Okay. Thank you, sir.
Thank you. So please log out. I think I see 3 people are still there.
Yes, I'll log out. Yes.
Log out.
Thank you, sir.
Thank you.